Welcome to Algebra 1. We will discuss operation with rational numbers. We have two rational numbers and perform some operation with these two rational numbers. The operation can be addition, subtraction, multiplication, or division. We want to know if the end result of the operation is still a rational number. Let's find out in this video. Let's first define what is rational number. Rational number is any number can be expressed as a fraction of two integers in the form of P over Q. So integer, fraction, terminating decimal, and repeating decimal, they can all be expressed as a fraction of two integers. So they are all rational number. The first question we want to answer is, if the sum of two rational numbers is always a rational number. Let's see an example. I have a two rational number, 1/2 and a 5/3. I add them together because they have a different denominator. So first, I need to form a common denominator, which is 2 times 3. The first fraction, I multiply by 3 on its numerator and denominator. So first fraction become 1 times 3 and 2 over 2 times 3. The second fraction, I need to multiply by 2. So the second fraction become 2 times 5 over 2 times 3. Now the first fraction becomes 3, 6, and the second fraction become 10, 6. Now they have a common denominators. I just need to add the numerator together. So the numerator becomes 13 and denominator becomes 6. This is a rational number because it is a fraction of two integers. So the sum of these two rational numbers is still a rational number. But is this still true for arbitrary two rational numbers? We have to prove. First, we need to assume we have two rational numbers, A over B and C over D. These two numbers can represent arbitrary two rational numbers because A, B, C, D can be any integer and B and D cannot be equal to 0. Now we add these two arbitrary rational numbers together because they have a different denominator. So I need to find the common denominator, which is B times D. So the first fraction, I multiply by D on its numerator and denominator. So the first fraction become A times D over B times D. The second fraction, I need to multiply by B on its numerator and denominator. So the second fraction, C over D, become B times C over B times D. Now they have a common denominator of BD. So I just need to add the numerator together. AD plus BC become my numerator, and common denominator BD copy over as my denominator. So my final answer is a rational number because its numerator AD plus BC is an integer and its denominator B times D is also an integer and is a non-zero integer because B and D cannot be equal to 0. So we just prove for any two rational numbers, the sum is still a rational number. Now we want to answer our second question. Is the product of two rational numbers always a rational number? Let's see example 2. So I have a two rational number here. 1/2 times 5/3. I can multiply their numerator together. 1 times 5. I can also multiply their denominator together. 2 times 3. So the result will be 5/6, which is a rational number because it's a fraction of two integers. For these two rational numbers, their product is a rational number. But if this is still true for arbitrary two rational numbers, so we need to prove. First, we need to assume we have a two rational number here, a over b and c over d. A over b and c over d can represent any two rational number because a, b, c, d can be any integers and b and d cannot be equal to 0. If I multiply these two arbitrary rational numbers together, a over b times c over d, I can multiply their numerator together, a times c, and I can also multiply their denominator together, b times d. The final result is still a rational number because a times c is an integer and b times d is also a non-zero integer because b and d cannot be equal to 0. So we have proved the product of two rational numbers is always a rational number. Now you can pause this video and work on these two problems by yourself. After you solve the problem, you can continue the video and check the answers. I hope you learned something from this video and thank you for watching.